Hey there, coming at you from West Virginia. Hope everybody's doing well. And I think it's time for joke of the day because it's the best part of the day. So, you know, I used to have a fear of hurdles, but then I got over it. That's shout out to all my hurdlers out there and track stars. So let's hurdle ourselves into multiplying polynomials. So, when you multiply polynomials, you need to understand, as you can see in this example right here, that whenever something sits up against something else, that always indicates multiplication. I've mentioned that to you before. Sitting up against means multiplication. So I have this -5 sitting up against that y, meaning those two are being multiplied. But on top of that, this term, -5y, is sitting up against a parentheses, which means this term, -5y, is going to be multiplied to the parentheses. The parentheses is there to indicate this -5y is not just being multiplied to this term, it's being multiplied to every single term in the parentheses. So that means typically when we multiply polynomials, we're going to use our distributive property. The distributive property basically can be expanded to include variables and not just numbers. So that means I'm going to take this -5y, and like I said, I'm going to multiply it to every single term that's inside that parentheses. So when I take the -5y and I multiply it to the y to the third power, a -5 times 1 is a -5. But then when I do y to the first times y to the third, remember we just learned that when you multiply the bases, you add the exponents because of the product of powers property. So I'm going to keep that base because it's all about the base, and then I'm going to add up those exponents. A 1 and a 3 gives me a 4. So this becomes -5y to the 4th. Then, when I multiply my -5y to the -6y squared, well, -5 times -6 is a positive 30. But then, when I multiply those bases, y to the first times y squared, once again, it's all about the base. So I'm going to keep that base, and I'm going to add up those exponents. And I'm going to say 1 plus 2 will give me 3. I'm going to continue that on, taking that -5y and multiplying it to a 2y. -5 times 2 is a -10. And then y times y will be y squared because 1 plus 1 will give me 2. And then finally, -5y times 6. -5 times 6 is a -30. And there are no other y's to be multiplied to that y, so it's just a y. Now remember, if I can combine like terms, I should. How do you recognize like terms? Remember, they have the same variables, but those variables are raised to the same power. They all have the same variable, they all have a y, but none of them are to the same power because this is 4th power, 3rd power, 2nd power, 1st power. So I cannot combine up any of them. None of them are like terms, and that's as good as that one gets. Now, if we take this idea of the distributive property, we can expand that distributive property. Take, for instance, the example that we see right here. What I have is an x plus 5 within the parentheses and a 3x plus 2 within the parentheses. Those two parentheses are sitting up against each other. And remember, sitting up against always indicates multiplication. So it tells me I'm taking this entire parentheses and multiplying it to this entire parentheses. So if the whole parentheses is being multiplied to the whole parentheses, what that means is every term here is being multiplied to every term here. So that would indicate that I'm going to take that x and I'm going to multiply it to the 3x, but I'm also going to multiply it to the 2. And then I'm going to take that 5 and I'm going to multiply it to the 3x, and I'm going to multiply it to the 2. Now, a lot of you may be thinking, wait a minute, that looks like what I've heard called FOIL. And it is FOIL. But FOIL, I prefer to think of as an extended distributive property. And I'll tell you why in just a minute. Remember, FOIL stands for first, outer, inner, and last. And what that means is I'm going to multiply my first two terms together. So here's the first two terms being multiplied together. I'm going to multiply the outer terms together, and here's the outer terms. So when I multiply these two and then these two, basically that's taking that first term and distributing it through the second parentheses. Then when I do inner, that's these two. And when I do last, that's these two. So basically that's taking the next term in the first parentheses and distributing it through the second parentheses. So FOIL is basically just an extension of that distributive property. Now when I do that extension of the distributive property and I take x times 3x, I will get a 3x squared because x times x, add up those exponents, 1 and 1 gives me 2. And then when I take x times 2, I just get a 2x. And when I take 5 times 3x, 5 times 3 is 15. And then when I take 5 times 2, I get a 10. But remember, combine up like terms if you can. Now I wasn't able to combine any like terms up here because even though they had the same variable, none of them were to the same power. But notice down here, I do have a couple of variables to the same power. So a 2x and a 15x will give me a 17x. And then I've got 3x squared that won't combine with anything. And I do have a 10 that won't combine with anything. So this is as good as it gets. But notice that, like I said, that extension of the distributive property, which a lot of us call FOIL, it can result in combining up like terms. Now, let me reiterate, I like to think of FOIL as an extension of the distributive property because what if there were more than 2 terms here? What if there's more than 2 terms here? Then I've got way more than first, outer, inner, and last. And so I'm not going to know what to do if all I know is FOIL. But if I think of FOIL as the distributive property, then I can put a ton of terms in this parentheses and a ton of terms in that parentheses. I will be completely fine because I will just simply take every term in the first parentheses and distribute it to the second parentheses. So I'll start with the first term, distribute it to the second parentheses. Pick up the next term, distribute it through the second parentheses. Pick up the next term, send it through the second parentheses, and continue to do that until I've used up all those terms in that first parentheses. So let's take another example and see what else could happen here with the idea of FOIL, or like I said, the extended distributive property. So let's take a look at this example. So remember, when the 2 parentheses sit beside each other, that indicates take everything in the first parentheses and multiply it to everything in the second parentheses. So I'm going to take that first term, I'm going to distribute it through the second parentheses, and when I do, 3x times x is a 3x squared. 3x times 5 will be a 15x. And I'm done distributing that one through. So I'm going to pick up the next guy and send him through. It's just I've got to be very careful about what I'm sending through because exactly what is going through there. Remember, the sign in front is the sign that goes. That name tag goes on the front. When you go to a meeting, you put your name tag on the front. You don't put your name tag on the back because I have no idea who you are. So you put your name tag on the front and you don't take it off until you leave the meeting. So right here, this is a -4. That's the name tag. So a -4 times x is going to be a -4x, and then a -4 times 5 is going to be a -20. And now I'm going to look and I'm going to say, are there any like terms that I can combine? And in fact, there are right here, 15x minus 4x. And if I take a 15x and I subtract a 4x, 15 minus 4 is 11. And we know that when we combine up like terms, we are going to work those coefficients and we're going to keep the variables the way they are because that's what's making like terms is the variables. We like that they're like terms. We're not going to mess that up. We're going to keep the variables. So that gives me a 3x squared plus 11x minus 20. There are no more like terms there, so I'm stuck on that one, and that's as good as it gets. Now, take a look at the next one. Just one more example to make sure we're very good at this. I've got a parentheses times a parentheses, so that means I'm going to take that first term, I'm going to distribute it to every term in the second parentheses. When I do, 7 times 10 is 70. 7 times -3y, again, name tag, sign in front's the sign that goes. That is a -3y. So 7 times -3 is a -21y. And I'm done distributing the first term through the second parentheses. So it's the next guy's turn. So I pick him up and send him through. I'm just going to be very careful about what I'm taking. That name tag goes with it. A -2y times 10 will be a -20y. And then that -2y times a -3y. Again, name tag right there stays with it. -2 times -3 is a +6, and y times y is a y squared. Now, I'm looking for like terms that I can combine, and I do have a couple of like terms right there with those y's. A -21y minus a 20y. Remember, since they're like terms, I like how they are. I'm going to keep that variable the way that it is, and I'm going to work those coefficients. And -21 minus 20 is a -41y. And I'm going to carry down my 6y squared because it doesn't combine with anything. I'm going to carry down my 70 because it doesn't combine with anything either. And so that's as good as it gets. Now some people, and oftentimes you're told to write this in descending order. Frequently I don't get real worked up about putting things in descending order. But if you were to put it in descending order, just make sure that, again, that name tag, that sign in front is the sign that goes. This is a positive 6y squared. So if I was to put it in descending order, I would say 6y squared. That's a negative 41y. And this is a positive 70. So if I needed to put it in descending order, that's what it would look like. Now, like I said, I like to think of FOIL as extended distributive property because you can see in this example I got way more than first, outer, inner, and last because I've got 3 terms in the back parentheses. So what I'm going to do is I'm going to think of this again as extended distributive property, and I'm going to take that first term and I'm going to distribute it all the way through the second parentheses, distributing it to every single term. So 2c times 4c squared, 2 times 4 is 8. C times c squared is c to the third, because we learned with our laws of exponents, when you multiply the bases, you add the exponents, and a 1 plus 2 will give me a 3. Then 2c times negative 4c, well, 2 times negative 4 is a negative 8, and c times c is a c squared. And now, 2c times 1 is just a 2c. So I've distributed the first guy through that second parentheses. He's done. He can't do anything else. So I'm going to take the next guy and send him through the second parentheses. Being very careful about what goes in there, that take that name tag with it, because when he leaves the room, he takes his name tag with him. So a negative 1 times 4c squared is a negative 4c squared. A negative 1 times negative 4c is a positive 4c. And a negative 1 times 1 is a negative 1. Now I'm ready to combine up all those like terms. So the highest power that you see is a third power on that c. There are no other third powers. So I'm just going to carry it down as I see it. And now I'm going in descending order. In descending order, I see a c squared right here, and I see another c squared right here. They're like terms because they have the same variable, and those variables are to the same power, so I'm going to work those coefficients. Negative 8 minus 4 is a negative 12. I'm going to keep the variable the way that it is because I like that they're alike. I'm not going to mess that up. I'm going to keep it the way it is. Now in descending order would be c to the first power here, c to the first power here. And I have 2 of these c's and 4 more of those c's. That means I've got 6 of these c's. Yet again, I'm going to leave those variables the way they are because that's what's making the like terms, and I like that. I'm going to leave it alone and work coefficients. And then this negative 1 in the back doesn't combine with anything, so I'm dragging it down, keeping the name tag on there. Sign in front's the sign that goes. None of these are like terms, so I'm stuck, and that's as good as that one gets. All right, one more, and then we're going to take a look at our vertical format with multiplication. So once again, I'm taking this polynomial, which happens to be a trinomial, and I'm multiplying it to this trinomial. See, way more than first, outer, inner, and last. So I'm going to use the idea of extended distributive property. I'm going to take that first term and I'm going to multiply it all the way through the second parentheses to each and every term, being very careful about those name tags. So x squared times x squared, when I multiply the bases, I add those exponents. 2 and 2 will give me 4. And now when I do x squared times negative 2x, well, 1 times negative 2 is a negative 2. X squared times x, again, add up those exponents because I'm multiplying the bases, and a 2 plus an understood 1 will give me a 3, so it's x to the third. And now x squared times a minus 1 is a negative x squared. So I'm done with the first guy. I've sent him through that second parentheses. It's the next guy's turn. So he's going to be distributed through that second parentheses, and once again, all the way through. So 3x times x squared, I'm multiplying those bases. I'm going to add the exponents. A 1 and a 2 is a 3. So I've got a 3x to the third out of that. And now 3x times negative 2x. Well, 3 times negative 2 is a negative 6. X times x is going to be x squared. And 3x times negative 1 is a negative 3x. So I'm done sending the second guy through. It's the last guy's turn. So I'm going to take that 1 and I'm going to distribute him to every single term. And 1 times anything is itself. So that x squared will carry down. That negative 2x will carry down. And that negative 1 will carry down. And now I'm ready to combine up my like terms. So x to the fourth power is the highest power that I see. And I don't see any other x to the fourths. So I'll just carry that down as an x to the fourth. Now working in descending order, I see an x to the third right here. And there's another x to the third right there. And that's all of them that I see. So I have a negative 2x to the third plus a 3x to the third. And that will give me a 1x to the third. Because yet again, like terms, I like how those variables are. I'm going to keep what's making them alike. The variables is what's making them alike. I'm only working coefficients. Negative 2 plus 3 is 1. And now in descending order would be second power. So I see a second power here, I see a second power here, and check it out, I see a second power there. So a negative 1 minus 6 is a negative 7. Negative 7 plus 1 is a negative 6. So, and essentially, this negative x squared will cancel out this positive x squared, and I'm just left with this negative 6x squared. And then working in descending order, I see first power right here, and I see first power right here. So a negative 3x minus 2x, again, work those coefficients. Negative 3 minus 2 is a negative 5. And I'm going to keep that variable the way that it is because I'm simply combining up like terms. That's all I'm doing. And then finally, this lone little constant in the back. Carry him down because he doesn't combine with anything. None of these are like terms. Yes, they do all have the same variable, but those variables are not to the same power. So I'm stuck, and that's as good as that one gets. So this is how you multiply polynomials when they are in that horizontal format being that you're going to just string it left and right. And now I'm going to show you what happens when you have vertical format. So let's flip this thing around and clean it up and get ready for that vertical format. Now remember, we said that vertical format, a lot of people like that when they're adding and subtracting polynomials because it shows us exactly where those like terms are, it lines everything up, like terms are easy to find. But multiplication in vertical format is a little bit more challenging, so a lot of people don't like it whenever they're multiplying in vertical format. So I'm going to do more examples in vertical format. And in each one of these, I'm going to multiply. So let's take our first example that says y squared minus 5y plus 3. It is being multiplied to a 4y minus 5. So it's basically saying this would be my trinomial and the binomial would be back here, but it's in this vertical format. So what I have to do is I have to remember that what that would indicate is I'm going to distribute this term to every term in the first parentheses. I'm going to distribute this term to every term in that parentheses as well. Or I could say I'm going to distribute this one to every term down here, distribute this one to every term down here, and distribute this one to every term down here. So if I look at it that way and I say, okay, let's make that distribution happen, multiply this to both terms. So y squared times 4y will be a 4y to the third. And then y squared times a negative 5. Still work with those name tags. The name tag on that 5 is a negative. So I get a negative 5y squared. Now when I continue with this idea of the distributive property, and I'm taking that first parentheses and distributing it to the second parentheses, it's this guy's turn. He is now going to be distributed to both of those terms. So a negative 5y times a 4y, well, negative 5 times 4 is a negative 20, and y times y is a y squared. And now negative 5 times negative 5y, or sorry, negative 5y times negative 5. Well, negative 5 times negative 5 is a positive 25, and I just have a positive 25y because there's no y here to be multiplied. And then finally, I'm going to take this guy and I'm going to distribute him all the way through. So he's going to be multiplied here and here. And 3 times 4 will be 12y, and I'm running out of room, so I'm just going to write it down here. And then 3 times negative 5, sign in front of the sign that goes, will be a negative 15. Now I'm going to combine up those like terms, and I have a y to the third power, but there are no other y to the third power. So I'm going to carry that down. And now I'm looking for, here's a y squared, and right beside it's another y squared. That's handy. So remember, when I'm combining up like terms, I'm going to keep those variables the way they are because that's what's making them alike, and I'm going to work those coefficients. So a negative 5 minus 20 is a negative 25. Whoops, that's a y squared. Excuse me. And then I'm going to go in descending order, and I'm going to combine up this y and this y, a 25y plus a 12y. Again, I like the way it is. I'm going to keep that variable. I'm going to work those coefficients. 25 and 12 is going to be a 37. And then this lone little 15 in the back doesn't combine with anything, so I'm going to carry him down, keeping his name tag with him. And none of these combine because none of them are like terms. And that's as good as that one gets. So let's try one more in this vertical format. And I've got an x squared plus 6x minus 4 multiplied to an x squared minus x minus 2. Whole lot more going on there, and hopefully you can see why I don't like to think of it as FOIL. To me, it's the extended distributive property. So I'm going to take everything in this trinomial and I'm going to multiply it to everything in this trinomial. So I'm going to take the first guy and send him through. So x squared times x squared, I'm going to keep that base because it's all about that base, about the base. I'm going to add up those exponents. 2 and 2 will give me 4. And then x squared times, keep that name tag on there, that's a negative x. So positive times negative is negative, and x squared times x is x to the third, because yet again I'm going to add up those exponents. And x squared times negative 2 is a negative 2x squared. So the first guy has been distributed through. Now it's the next guy's turn. So this 6x is going to take his turn, and he's going to multiply here, here, and here. So 6x times x squared will be a 6x to the third, because I'm going to add up those exponents since I'm multiplying those bases. 6x times negative x, well 6 times negative 1 is a negative 6, x times x is x squared. And then 6x times negative 2. Positive 6 times negative 2 is a negative 12, and I get a negative 12x. And now it's the last guy's turn to be distributed through that trinomial. So this negative 4 is going to take his turn to distribute all the way through. So a negative 4 times x squared is a negative 4x squared. Yet again, I'm running out of room, so I'm writing it down there. Negative 4 times negative x, well negative 4 times negative 1 is a positive 4, so I get a positive 4x. And then finally, negative 4 times negative 2 will be a positive 8. So I've done all the distribution. It is time to combine up those like terms. So here's my fourth power, and there aren't any other fourth powers, so I'll leave that one alone. Now I'm going to go in descending order. Third power, so I've got a third power here, I've got a third power here, and that's all the third powers. So a negative x to the third plus a 6x to the third. Now remember, I'm not adding up exponents now because I'm not multiplying any bases at this point. At this point, I'm combining up like terms. So I like what's making them alike. That's those exponents, the variables. I'm only going to work coefficients. A negative 1 plus 6 will be a positive 5. So I get a positive 5x to the third. And now going in descending order, next will be a second power. So I've got a second power here, and ta-da, another second power right there. So when I combine those, again, I like that they're alike, so I'm going to keep those variables the way they are, and I'm only going to work the coefficients. So a negative 2 minus 6 will be a negative 8. Negative 8 minus 4 will be a negative 12x squared. Moving on down the line, now I'm going to be dealing with my first power. So I've got a first power here and a first power here. And again, what's making them alike is the variable, so I'm going to keep it the way it is. I'm going to work those coefficients. So negative 12 plus 4 will be a negative 8. So I get a negative 8x. And then that lone little constant in the back, that 8, doesn't combine with anything, so I'm going to carry him down with his name tag. None of these are like terms, even though they all have the same variable. None of those variables are to the same power. And so I'm stuck, and that's as good as that one gets. So even in vertical format, the idea is when you're multiplying polynomials, you distribute every single term from the first polynomial to every single term in the second polynomial. Use your laws of exponents to multiply, and then just simply combine up like terms after that. Hope it helps. Have a great day.